I hope you're all doing well. I'm Mr. Ish. Thank you for joining me. If you are given a task to expand that function e to the x hyperbolic sine x, two distinct functions which are in a product relationship, but you have to expand the series by means of Taylor or Maclaurin series, it would be difficult. Because when you start getting to higher order derivatives based on the template you see for that type of a function, it would be a very difficult task. If someone asks you to expand this, you know it's easy. Something like this is easy. These standalone single functions are easy. But a compound function like that, well, it presents a difficult task for us to worry about. But how can we do something like this in an easy way? You can. You split everything into two different parts. You would focus on each part individually. You would focus on e to the x. You know, in terms of higher order derivatives, it's always e to the x. For a series centered around a equals 0, it'll always be 1. When you expand this, you know it's easy, it's not hard. You will have here 1 times x to the power of 0 over 0 factorial plus 1 times x to the 1 over 1 factorial plus 1 times x squared over 2 factorial, which is a 2, plus 1 times x cubed over 3 factorial, which is a 6, plus 1 times x to the 4 over 4 factorial, and lastly 1 times x to the 5 over 120, and you can go on and on. So that's easy. When you have to do these individually, it's easy. And then you do the same thing for hyperbolic sine. Expand this by means of Maclaurin series centered around a equals 0. It always shuffles in terms of higher order derivatives between hyperbolic sine and hyperbolic cosine. I'm just writing them as abbreviations. When a is equal to 0, hyperbolic sine is a 0. When a is equal to 0, in terms of the derivatives, and you're putting 0 for the hyperbolic cosine, you're getting a 1. So we'll shuffle back and forth for this coefficient part right here between 0 and 1. Your first term will be 0 x to the power of 0 over 0 factorial, and then the next one will be 1 x to the 1 over 1 factorial, and the next one will obviously be 0. I won't even write the rest, and the next one will be 1 x, this is 0 1 2 x cubed over 3 factorial, and then you can get the picture on, and it's not hard. You'll have 1 x to the 5 over 5 factorial. What we need to do now is write these out in a clean manner, and we can. When you're looking at this exponential, it becomes this. You have 1 plus x squared over 2 plus x cubed over 6 plus x to the 4 over 24 and x to the 5 over 120. You know you can write more, but I won't write more. And then when you look at the hyperbolic sine and you clean that up, look what I'm doing over here. I'm not writing hyperbolic sine over here, but it would fit right over here because I have exponential then hyperbolic sine. What do you get? This zeroes out. Don't even write it. Here you get a x. And then you can skip the 0. X cubed over 6. Skip the 0. X to the 5 over 120. And then you know x to the 7 over 5040. We have all of that coming into play. And now I'm erasing this. Because what do I have here? I have the exponential. I have the hyperbolic sine. In terms of their series expansions, you know each will continue on and on, but it mirrors this. Now doing the series expansion utilizing this breakdown approach is easy versus looking at this as a single unifying function. It would be very difficult. All you would have to do is now find all the combination of product terms that you have. You know, it's just like multiplying a polynomial with a polynomial. But look, the first term here, you know the first term has to be an x, and that would be your x to the 1 term. Then you want to find an x squared term, x cubed term, x to the 4, x to the 5, and let's stop at x to the 6. These are the varieties of terms we should find as an initial set of expansion of that series. The first one is easy. 1 times x is x, and we'll stop over there. X squared. But again, you have to find all the combination of products you would see which would give you each of these terms, always using this initially multiplying with something over there. To get an x squared term, I can do x times x, and I'll have an x squared, but there's no other way I can get an x squared term. So that part is done. Now we look at the x cubed term. You can get an x cubed term in the following way. This 1 times this x cubed over 6. 1 times x cubed over 6 is one way I'm getting it, and all the combinations will add. What's another way you can get an x cubed term? How about this? X squared over 2 times x, that will give you an x cubed. X squared over 2 times x, and there is no other way, so you have to compute all of this. X cubed over 6 plus x cubed over 2. Common denominator 6. You will have an x cubed plus 3x cubed. What will you have? 4x cubed over 6, and it will be 2x cubed over 3. That will be your next term, 2x cubed over 3. We've determined that. Now we have to find our x to the fourth term by finding all the varieties of combinations which would give you that. And what are those combinations? How about this? X and x cubed over 6. X times x cubed over 6. That's one combination. Is there any other combination? There is. X cubed over 6 times this x cubed over 6 times this x, and that's it. You'll have x to the 4 over 6 plus x to the 4 over 6, which is easy. 2x to the 4 over 6, which is x to the 4 over 3. That's your next term, plus x to the 4 over 3. Again, we are expanding this by means of Maclaurin series, but you looking at this as a single function is very difficult. We've separated this into two different things in terms of their individual series expansion. Then now we're multiplying the series expansion because that's so much easier than looking at this. Now we have to find all the combination of ways you can make an x to the 5 term, and I'm seeing several. How about this? 1 times x to the 5 over 120. 1 times x to the 5 over 120. That's one way. How about x squared over 2 times x cubed over 6? That'll give you a x to the fifth term. X squared over 2 times x cubed over 6. There seems to be one more, x to the 4 over 24 times x. And now bring all of these together. You have x to the 5 over 120 plus x to the 5 over 12, and lastly x to the 5 over 24. That's what you have. What's a good common denominator over here? Well, it'll likely be 120. 120 goes 120 one time, so that's just x to the 5. 12 goes in that 10 times, 10x to the 5. 24 goes in it 5 times, 5x to the 5. Now look, 1 plus 10 plus 15 is a 16x to the 5 over 120. Simplify it, and you'll get your this term right over here. You'll have 2x to the 5 divided by 15. That's your next term. 2x to the 5 divided by 15. And we will stop right here at the x to the sixth term. But generally, you know, you'd keep going on and on, but of course we will not keep going on and on. What are all the ways you can come up with an x to the sixth term? I'm seeing one right over here. This x times this x to the 5 over 120. X times x to the 5 over 120. How about x cubed over 6 times x cubed over 6? That'll give you an x to the sixth term. There must be one more. There is x to the 5 over 120 times this x. That'll give you what you need. Now bring them together. X to the 6 over 120 plus x to the 6 over 36, and lastly x to the 6 over 120. When you're looking at these numbers, you're looking at a 360 common denominator. 120 goes in it 3 times, 3x to the 6. This goes in it 10 times, 10x to the 6, and obviously this is the same, 3x to the 6. You're having here 16x to the 6 over 360, which you want to simplify. You will end up with 4x to the 6 over 90, but again it can be simplified further, 2x to the 6 over 45, and that's your next term, and then obviously the series will keep going on. So now let's verbalize everything we've done. Our task was to determine the Maclaurin series expansion of this, which is difficult. It's a compound function, or it's a combination of two different functions in a product relationship. It would be difficult. Separate them into their individual functions, do their individual series, multiply the series together, find all the combination of products that will give you the terms you need. You have your x1 term, x squared term, cube, 4, 5th, 6th term, and you keep going on and on, but then that would be your series. But this here is our series. X plus x squared plus 2x cubed over 3 plus x to the 4 over 3 plus 2x to the 5 over 15 plus 2x to the 6 over 45. But these are 1, 2, 3, 4, 5. The first 6 terms. That's what they are. The first 6 terms of this series, if you were to expand it using Maclaurin series, that's what I'm showing you right over here. Thank you.